Okay. Thank you very much for a very generous introduction. It's a privilege to be here. At the outset, I would like to mention that ISRO is something that really inspires the nation, and the outstanding work that it has been doing in space exploration and India's space capabilities is known to everyone, and really fills everybody with a lot of energy and excitement. It is also important to mention that ISRO's technologies is not just about exploration, but they have byproduct applications ranging from understanding of the Earth itself, its own climate, as well as applications far-reaching as health and education, etc. For example, the satellites and other space-borne vehicles that are sent, they're able to connect various parts of the country, and educational messaging and many other parts of information. Any information which was earlier difficult is now provided through that. And also the early warning and many other pieces of geospatial work that ISRO does is again of tremendous values to everybody. Many of us don't realize that we touch pieces of ISRO technology at a very, almost a daily basis. So I'm, with that gratitude to ISRO and also to this initiative of trying to connect different technology fields with young minds and share ideas at scale, I begin my presentation. I work largely in the area of hardware design, embedded design, robotics, and now artificial intelligence as well. So I'll share some aspects of that with relevance to ISRO's mission. So this presentation is in two parts, and it's a short presentation so that gives us time for also interacting later. Initially, I'll talk about robotics and more generally embodied AI as an emerging technology which is going to have an impact in a variety of different areas, ranging from human assistance in homes to factories to space exploration. The applications are wide. Then after the brief introduction and sharing some work in this area, I'm going to turn attention to the specific things which are relevant to space exploration and space science. So I just want to double check. Is the slide visible? Slide visible? Great, thank you. So let's begin with part one, which is on the topic of intelligent robotics. And what does this really mean, and how do we think of this in the emerging scenario of artificial intelligence? So the first point I would like to make is that if you look at our civilization and our own evolution, our society has been propelled forward by our ability to affect the physical world towards things that we actually desire. Towards our objectives, we've been able to manipulate the physical world in a certain way. So if you go back to the agricultural age, when agriculture got transformed by implements, and the Indian civilization and many other civilizations as well show evidence that people used to make metal tools and use animals in a certain way to increase agricultural productivity. After that, what happened was the invention of the steam engine, and that led to the industrial age. And the steam engine suddenly made transport possible to large distances. It increased industrial production, and looms came up, many other production kinds of establishments started, and then the industrial revolution obviously began. Now, following which, more closer to our times is the electronic age, when computers are now becoming ubiquitous, and computers not just in the form of a desktop, but also these kinds of phones that we carry. They have a lot of computation which is happening. They are displaying information. They're allowing us to interact with information. They're allowing us to make a lot of calculations, and which is making our life really, really good. Now, if you go from the agricultural to industrial to electronics age, what has fundamentally happened is that our per unit ability to affect the physical world towards our objective has increased. Right? Now, the future extension for that is for intelligence aspect to not just reside on the computer, but also start residing in other either machines or systems that we interact with. And let us call this the age of the robotic age, or the age of embodied artificial intelligence. Now, one way to think of this would be that in the 1990s, when we had computers, computers were large. They used to be kept in one particular place. We never had cell phones as well, and we never had smartwatches. Now, over time, computers became smaller. They got connected to better sensors, and now computers are everywhere. Computing is now pervasive, right? From our television screens to our watches to our phones to many other parts, computing has become pervasive. And the same thing is also going to happen or is likely to happen for artificial intelligence or any intelligent decision-making system as well. We're going to be interacting with intelligent systems all the time, and they're going to be assisting us. They're going to be increasing our productivity as we go along. So the modern way of thinking of robots is to think of this as more general embodied AI, which are intelligent agents capable of autonomous goal-directed behavior. Now that means that they take input from the environment in terms of sensing, as in images or text or other forms of individual modalities. And on the other side, they interact with us or they perform some kind of a action in the real world. Okay? So on the left-hand side, in some sense, you can think of this as traditional artificial intelligence, which is speech recognition or image captioning or many of the other newer things you're seeing, even ChatGPT. They all sort of lie on the left-hand side. When they are fused with the physical world in which we are living, or when they're interacting with us directly, then the fusion of these we call as embodied AI. Now let's take a specific example. And on the left-hand side, there is a picture of a robot. That robot is helping a soldier, let's say, handle a certain hazardous object. Okay, so for example, let's say, let's say some hazardous thing like an explosive or some other thing. The human does not want to go, but the machine is to be sent. Now, this particular machine, we can interact with it at a lower level. That means we can program every part. But let's imagine that in the future, we would like to have a machine which can do something like this. That we say, robot, secure a certain area. That means anything which is hazardous, you identify, you pick it up, you put it in a certain safe area, and then the task would be complete. That higher level ability to take a high level instruction and then break it down, that's the capability that we are looking at. Now let's just turn this, just pause for a moment and just think that if our mother is saying the same thing in the kitchen, then how would we process this? For example, if she says that, let me, please get me the pickle. The pickle is somewhere in the cupboard. Please get me and put that on the dining table, right? Then we would think about where that pickle is. We need to go, operate it, pick it up, open it up, and place it in some other kind of place, right? So if you look at that example, which is closer to home, we can identify that there are certain cognitive functioning or cognitive processes which are operating, going from the top level instruction to something that the machine is doing in the real world. Okay, right. So now let's see that we have to understand the intent of the instruction. We should know what the world state is, and then we have to perform reasoning and planning, and then finally behavior execution is to take place. So there's a lot of intelligence which is built into our brains is going to come into place, right? And that is the technical scientific challenge of bridging this gap between what the human wants and what the machine can actually do. Now, the machine may or may not be a physical robot. A lot of the times it will be, but it can also be a certain generic kind of a system that we're interacting with. Now, how do we model this kind of a system? As engineers, we are very good at block diagrams. So let's try to make a block diagram where we have the robot. The robot is going to take some information from the environment. Let's call that a state. And it is going to generate a plan, a sequence of actions that once executed in the environment are going to take the robot towards what the human was intending to do. So this is what is called a classic AI-based agent architecture, in which there's an agent that lives in the environment. It consumes observation and generates action, consumes observation, generates action, and then so on and so forth. It keeps proceeding all the time, right? Now let's take certain examples of this. These are certain examples from our lab, which give an idea about how these kinds of things can be realized. So on the left-hand side, you see there is a robot which has a ground base. and it has an arm, and it is able to pick objects either on the ground, on top of another object, or from inside from another object. So this is picking happening on the left-hand side. Below, you see placing of objects. The object that was picked up is put gracefully on the side. It is put gracefully on top of another object or also inside some other container. Right? Now, actions are low-level control routines, but they also have semantics associated. For example, you can pick an object only when there is nothing on top of it already, right? So if you say that there is some object here, there's something on top of it, I cannot pick up the lower object before having picked and removed the object on top of it. So there are certain preconditions and there are certain post conditions which are also there. Once an object is picked up, it is not there in its original position and it is there in my hand, right? So these are the semantics that we also need to take into account when we're synthesizing long horizon tasks, when we compose these things into one another. Now, when you look at a machine of this kind, a robot of this kind, it's important to remember what all does it have. It has sensors, so it has cameras, it has LiDAR, it has an arm that can lift and then grab something, it has wheels. And also there is a small computer, which is the brain, where the intelligence software is running. Typically, it's an embedded computer, an embedded system on which this intelligence is being encoded. Now with this, let's consider the example of a robot being asked to clear the debris in front of it. So there are certain objects which are there, and we want the robot to actually pick it up and move it away, right? So, so let's say the robot actually wakes up. Okay, so this is robot's hand. It is picking. It is going to a certain position, and the cameras on the hand are looking downwards, and they're trying to identify what all objects are there. So after that, once it does some visual scanning, it'll know that there is a pipe and there is a box in front. Then it recognizes it and also tells that I have these objects in front of me. And then the human commander is going to then say that, okay, search for objects in the front and then finally clear the objects. So now the robot is waking up, it's looking at its surrounding, building a model of what all objects are there, and then it will start interacting with it. Okay, so I'll see this like a child, there's a visual surveying. Let's say in the kitchen, you want to find a pickle bottle. So then you'll go and then you say, I found some object. So here it said that it had a case and a pipe in front. And then it will be asked to clear the object, clear the objects in front. And when that happens, clear the front, it is going to synthesize some sub-actions, which is going close to an object, picking it up, picking up another object, so on and so forth. It will break down that task and then start fulfilling it. Okay, this task is called planning, which is sequencing of smaller level actions one after the other, so that the larger, temporally extended action can actually be performed. Okay, so it picks this object, it can put it on the side, it can put it on the other vehicle on the left-hand side, and so on and so forth. Right. So from atomic sequences of low-level controllers, we get the ability to think of action at a semantic level and can compose them one after the other. Right. So it's putting this on the side. Now, if I fast forward this video, then it'll also pick up the pipe. So it's picking up the pipe, and then it'll gracefully pick up the pipe and put it on the side, right? This kind of a clearing has happened. Okay, so what we're able to see is this ability to go from language to certain high-level intent to objects being picked up and put on the side, right? Now let's look at another example where there's also navigation involved. Okay, so let's say a robot has to go behind a barrier and see if there is something suspicious lying there. So you saw that there was a barrier and there were some objects on the side of it, and the robot is unaware of that object. So the robot is asked to search behind the barrier. So now it will start moving. It avoids certain objects, right? And it will go behind that particular barrier. So once it goes, it's you will see it being behind. Once it reaches behind, it's going to double check that is it really behind or not. Okay, so it will say that, okay, from here it will raise its hand and then check that I'm actually close to or behind the object, which is the wall, and then I can start executing the exploration actions like what is there on the ground, etc., etc. Right, so some of this research has been motivated by assisting soldiers who need to explore dangerous areas. So you would like to actually explore a certain area before the soldier goes. So these kinds of technologies are built for that kind of a application. But the core is that there is now exploration. The robot can actually explicitly go behind a certain area, find objects, and then proceed accordingly. Right? Now there should be some questions in your mind. The question would be, let's say, how does a machine actually see the world? So the machine sees its world through sensors. So this is LiDAR sensors, which are essentially a laser beam, which is sent. And that laser beam hits certain objects and then tells if there is a certain object present there or not. And by this hitting, if you accumulate them, you get something like a map. So here the robot is moving around and it's getting these laser scans. And with that, it is able to fuse and get information about the geometry. So this is from a lab. So it is inside the lab. Then it moves around. Then it goes outside and then it's able to get information from other parts and build a coherent large scale map of the environment. Now notice that this is what the machine will now think about the geometry of the environment in which it is operating. And once it has built a map, it can be asked to go from one location to another location. Right? Then it can start saying that, OK, I'm going to move in this particular way and then go in this other direction. Right? Now, LiDARs have certain advantages. They, unlike cameras, can see in the dark. They're not affected by dark because they're sending a certain laser beam on this, right? So they are good to understand the higher level 3D structures. Now you get the 3D map of this entire, our lab is only this part. Now we'll be able to construct the map of the entire area. And this map itself can be useful, but it's also useful for the robot to navigate. Right? Cameras everybody knows about, so I'm not going to talk about it. These are sensors that look at the environment, get some information about colors and so on, and then we can perform the optical processing from this. Okay. The other aspect about intelligence that I would like to highlight is the fact that the agent is interacting in the environment. Right? So robots have the capability to fiddle with objects and then build their model. What is their geometry? What is their appearance? Where are they kept? Can I push them away? So a lot of probing can happen, which is a form of exploration. So on the left-hand side, you're seeing two robot arms taking an object and then manipulating it, building a model. On the right-hand side, you'll see a robot which is going to push away a certain object. Now this object, its mass and other properties are not known. So what does the robot do? So the robot will actually make contact with the object, right? Just fast forward it. And then, like a child, it is going to try a little bit with different force values to try and move it, to see whether it's even movable or not. Once it is actually able to overcome that friction, static friction, then it can execute in the dynamic phase and then complete the task. Okay? So this is probing. Initially, it did not know what is the mass, can it even move, and so on and so forth. And then it tries to push a little bit further and then get the exact information on this. Okay. Right? Everyone with me? Now let's turn our attention to even higher order thinking or higher order reasoning. Okay. So on the left-hand side, now we're talking about human collaboration, where there are certain objects in front of the robot, and we would like the robot to hand over certain objects to me. Right? So there's a human here, and the human says, bring the green colored towel to me. And the towel is somewhere here. Right? So the robot scans and then is going to then pick up the towel, picks it up, and then finally delivers it to the human's hand. So it was able to detect the human, what all objects are there. It is able to understand this high level instruction and then finish the particular instruction. Right? So in some sense, it performed a spatial reasoning. That means higher order understanding about objects in its environment, and then pick up that object and place it in some other location. Now let's see the same thing, spatial reasoning operating in time domain. Right? So on the right-hand side, you're going to see my colleague Nadir, who's going to bring different bottles and put one bottle, the second bottle, and the third bottle on the shelf. And he's going to go away. The robot is watching. Now another person comes in, another colleague, who says, give me the bottle that was placed second by the person. And see the bottle that it is going for. There are three bottles. It figures out the one that was placed second. That means this has the ability to maintain some kind of a memory. It can go back in time and reason about when certain interactions have happened. And with those interactions, it is effective to figure out that this is the bottle that you needed. Right? Now, this is really interesting. That gives the ability for the machine to see what is happening and then respond appropriately, even when there is a change, of the person. So on the left hand side, you see spatial. On the right hand side, you see extension to temporal reasoning taking place, right? So these are little snippets of what this technology or this emerging technology is. I would like to mention that what is happening here is some form of object detection and scene representation. That means there's an AI system which recognizes certain objects in an image and stores where their location is. Now, when we ask for a certain object to be retrieved, then the robot is able to figure out that this is the object in a certain area that is to be picked up, and it is going to be put in a certain different size. So that's the object recognition or visual recognition, and the camera is there on the hand, right? Like we also have a neck, we have a head, and we can look around, and then we can do certain interactions. Similarly, the machine also is equipped with these kinds of sensors. It also has a mic, it also has acoustic sensors, and it can speak and it can communicate bidirectionally to it. Some of these have been motivated by assistive applications. In the future, these machines are going to be in our homes, they're going to be in our hospitals. They're going to be caring for, let's say, people who cannot move on their own. They'll be looking after the elderly or people with disabilities, right? So these technologies are being invented for that kind of an application. But there is this fundamental thing about human-machine interaction, which is what we are trying to build. Now I'm complete with the first part. Now I'll briefly talk about the relevance to the space program of some of these technologies, right? Now these are broad technologies. They can have an impact in assistive domain, manufacturing domain, educational domain, many other domains. But today let's talk about space science and the exciting applications there. So one of the most exciting things here is that space is an unforgiving environment. Okay, it's it's near vacuum. It's inhospitable conditions, and robotic explorers is the way that exploration is going to happen in the space. And if you are aware of the recent missions being planned for the Gaganyaan mission, which is going to send an astronaut into the orbit and into space, preceding to those missions, there are going to be 3 unmanned missions which are going to take place. So this is a humanoid robot called Vyomvitra, which is being developed by IIRS-ISRO, and that has a humanoid torso. It has a head, it has hands, etc. And these hands are human-like. Okay, so they can actually touch a panel, they can see a certain display, and they can read what the display is. So they are AI powered as well. And this machine is going to basically first collect data that is the flight and the environment even safe for humans. It is going to give that kind of a information. So before going to a dangerous kind of an environment, the machine goes first, and it is going to generate all this data, and it is going to help us eventually plan these missions further, right? So this is under development, and this year hopefully we will see this getting launched to space. Similarly, recently in the last the mission, the SpaceX mission, where there was a docking of 2 satellites that was attempted, there was another series of experiments which were carried out as POEM. So as part of POEM, what was demonstrated was an indigenously developed arm like this, which was moving around in the blackness of space. Okay, so the arm basically lifted and then moved to different positions. And this is the first demonstration for a space robot happening from India. So this is very exciting. Now, this has many applications. This can be used to examine the exterior of a spacecraft, whether there is some damage or what is the condition outside the spacecraft. Okay, it can also perform some kinds of repairs. Okay, in the future, maybe it can repair a certain kinds of things which are very hard to do. You'll have to send somebody there, and that's very dangerous. Can the machine actually do that for us? Maybe a solar panel or assess damage or replace or reinforce or things of that kind, right? And third is actually capture of a satellite, right? So say something which is actually adversarial or not in control. Maybe can you capture that kind of a satellite? Or even if it's a normal satellite, can you capture it, then replace some parts of it, and then send that back into orbit? Some kind of orbital servicing is likely to be the next generation of this technology is going to lead into that direction. Okay, but it's very exciting. This is actually operating in space, and this is very interesting thing. Okay, so in future there are other countries that have been working on this kind of technology, and they're also exploring different concepts. For example, this is an arm which is helping an astronaut explore the outside in a spacewalk environment that is being done. This is some concept for satellite capture and then doing operations with it. And typically these are extravehicular operations, and the astronaut from inside has the ability to control the robot outside through a certain kind of an interface, which is a joystick kind of control is there, and then you can control that, right? So the human is always there. Okay, so the machine may be operating in a certain way, but the human is guiding it or controlling it, right? So the human aspect is always there in these kinds of systems. Now let's turn our attention to traditional exploration. Okay, so let's turn to space exploration on extraterrestrial surfaces. So almost everyone has seen the ISRO's Pragyan rover that was part that descended down from the Vikram lander and was exploring the south pole of the moon surface, right? And you saw that rover came down, and then it collected data, it performed some kinds of experiments, and it relayed information for scientists for analyzing, right? So this is something, again, we have not been able to go to the terrestrial body ourselves, but we can send these robotic explorers and they can do science for us. They can study mineral composition, they can explore what the environment conditions are. And because moon does not have an atmosphere, then it has different conditions in the sense that the sun does shine differently on this separate body, and it gives some cues about how the solar system itself was formed. Now we can send, people have been sending, different agencies have been sending robotic explorers to different places. So ISRO also has sent to Aditya L1 mission, which was a mission to the sun. Essentially, it's orbiting the sun in a certain, certain kind of an orbit. And there are certain additional details about Lagrangian points and those other things, but these are special orbits where you can actually monitor the sun, because we are always affected by the sun, right? If the sun's internal processes change, they have an impact on communication, they have an impact on our climate, and in general, the sun is obviously very important for life on Earth as well, right? Now, let's say Japan has sent a spacecraft on asteroids, and they're studying different properties of asteroids. Asteroids are small bodies, they reside in certain different parts of the solar system, and they've not been studied, and they're rich in minerals, and maybe we can extract minerals one day by this kind of a technology. And obviously others like developed world, US, and many others have been sending. So this is Mars Science Lab, which was an entire rover with almost like a chemistry lab on board, which was sent on the Martian surface to study different properties, look for water, and many other kinds of things, right? So these kinds of things are there, and typically where the technology is progressing now is increasing the ability to do physical interaction. That means digging or surface operation, or maybe in future when the astronauts need to go, the preliminary work in terms of paving the soil, doing some kind of habitat construction, performing initial experiments would be done by robots. Then astronauts would come in, there would be certain operations. When the astronauts leave, then the remaining science experiments will be carried out by these kinds of machines operating over a long time. And that's where the vision is, right? So you have new technologies currently in R&D phase, which are being developed in different parts of the world. On the left-hand side, you see scooping. So certain scooping operation is being done by lifting the soil, putting in a container, and then trying to bring it back. Let's say for a sample and return mission or for chemical analysis within the rover itself. Here you're collecting rock samples, picking them up because they have geology and many other things. And let's say a bimanual operation, two arms which come and do some kind of a construction sort of remotely on a different surface, which is there, right? So this is where eventually technology is going to go. Great. So I think at this point, I will try and conclude. So the two parts that we discussed was about intelligent robotics, that is machines that are AI powered and have the ability to understand human intent, understand the environment, do some kind of a reasoning, and interact with the environment, right? And for space, there are many applications. The applications on space station environments, right? For extravehicular, but also inside. Maybe inside the, India is going to have the Bharatiya Antariksh Station, where there are going to be experiments that are going to be done inside. And again, robots are being developed for that, for even the intravehicular activity. Extravehicular, we've already discussed, right? Then extraterrestrial operations on different surfaces, which are there, and I think that is going to add tremendous value to space science. And in the future, when humans are able to travel to other places, then some of the preparation and also continuation of human experiments would be carried out by robotic platforms, and that's where the technology is going. Right. So at that point, I will stop the presentation, and if there are questions, I can take the questions at